All right, so thanks for having me. So today we're going to talk about the GT summary package. If you have any questions throughout, just feel free to drop them into the chat and Kat will read them out loud to me. All right, so the whole motivation behind the GT summary package and why it exists. So I think we're all pretty familiar with the reproducibility crisis within research. Now that reproducibility crisis has a very long arc and there's lots and lots of pieces to it. But as statisticians and analysts and data scientists, whatever your role is, one thing that's an important part for our job is for reproducible reporting. So you get some data, you prepare that data for analysis in a very reproducible way, then you create a report that's also reproducible. Our Markdown really changed my life in this pathway because it really helped bridge the gap between my code, my raw output, and the final report. But I always felt that there was just these small changes that I still had to make after I would make an R Markdown report, tweaking tables this way and that way. So what we did within our department is we created an internal package it was called BioSetR. It's only available on the internal MSK network. And we really just wanted to create it to make the most common tables that we create as biostatisticians and make it very, very simple to make these tables, but also in addition to being simple, we wanted it to be very, very customizable so that we could get it exactly how we needed it. And hopefully doing this all in a very streamlined, nice, we try to make it tidy, if you will, framework. So that's what we did. And it was so good that we actually moved it outside of our internal networks onto CRAN, and now it's available everywhere as the GT summary package. So GT refers to the GT package created by our studio, which is for making tables. And GT summary is our package that uses GT in the background to create beautiful summary tables. So we're going to go over how to use the GT summary package. And again, you have questions, feel free to just raise your hand, type it into the chat. So the GT summary package makes a few different types of tables. Table 1 types that you see in your journals that you submit to, cross tabulations, summaries of regression models, summaries of survival data. If you use survey data, there are functions for that. And also, there's a bunch of functions that help all of these tables work together, merge them, stack them, add additional columns of information, so you can easily create custom tables as well. In addition to be able to creating those tables as part of our reporting, we often have to write reports. And in those reports, we are reporting numbers from those tables. And so there's an inline functionality too, where you can pass an entire table object and tell GT summary like, hey, here's a table. I need to pull out the odds ratio for age in this confidence interval, and it will put it right into your R Markdown report, which is fantastic. And we're going to go over some themes, and which are very quick ways to make a lot of custom option changes at the moment, and print engines, which we'll discuss at the end. So we're going to start with a very basic data example. And we're going to be using a data set called trial that comes within the GT summary package. It's 200 observations. All of these columns have been labeled using the labeled package. So while we have a column called TRT for treatment, it has a label that's, I think, called chemotherapy treatment or something like that. So here's what our data set looks like. We are going to be focusing on a smaller version of that called, we're just creating it here, small trial, which just has these 4 variables: treatment, age, grade, and tumor response. So just think of this as a study where half the patients-ish got treatment A, the other half got treatment B, and we know their age, we know their tumor grade, and we know if their tumor responded. So that's what we're working with in this data set. So the very first function that we're going to discuss today is TBL summary. It's the one I use the most often, and based off of Traffic website, I think everyone else as well. So here we are taking our very small data set here, a small trial. We are removing the treatment observation, the treatment column, excuse me, and we're just piping that data set straight into the TBL summary function. And you get this very nicely formatted table. So with, almost like a single line of code, you have a table that can be your table 1 in a publication, which is fantastic. So you'll see here, we have on the very top, age is a continuous variable, grade is a categorical variable, and tumor response is a dichotomous variable. So we didn't specify any of those types. The TBL summary function, it takes in your data frame and it tries to just guess, do its best to say, okay, well, this one looks continuous, this one looks categorical, and I think this one's dichotomous. So dichotomous are different from the categorical variables because they're displayed on a single row. So you can see here, tumor response is actually coded as 0 and 1, but we're only showing the one line because most oftentimes with dichotomous variables, you only need a single line to describe it. The default statistics for continuous variables are just the median and the interquartile range. And for categorical and dichotomous data, we just show the n and the percent. And by default, if there are missing values for a variable, we show a row for the number of unknown. And you can see here that while we didn't provide these nice labels, age, grade, and tumor response, because they were already labeled in the underlying data set, those labels were carried through. So I would recommend that you continue or start labeling all of your data in your data frames because it helps in a lot of different ways. So here's our most basic table. Now let's try to like change it and make it look a little bit cuter. So on the last slide, I said that there were actually 4 types of data. Continuous and continuous 2 were 2 of them. So on the last slide, we saw that age was just summarized on a single line. So continuous 2 does continuous variable summaries on 2 or more lines. So you can see in this example, we use the type argument to change age from its default of continuous to continuous 2, because we want to show statistics on 2 or more lines. So here we're showing the mean and the standard deviation and also the min and the max. And you can see here in the table on the right that you are getting the mean and standard deviation and the range. We've also used the by argument to produce these summary statistics by the treatment that the patients received. So you can see at the top here, we have drug A, drug B, and it automatically populates the number of observations for you as well. We're using here the label argument to change the default label. Now, if you don't label your data, it's just going to use the column names. And so you would be very commonly using the label argument in TBL summary to update that to something that's more human readable. So here we changed the label from tumor grade to pathologic tumor grade. And you can also see here that we're using the digits argument to show the statistics for age to 1 decimal place, whereas it defaulted to 0 decimal places. And how gtsummary picks how many decimals to round continuous variables to is it just takes a look at the spread of your data and says, okay, well, you have data going from 0 to 1 million. We don't need to present that data to many decimal places or any at all. So it kind of just takes a quick look at the spread of the data and then makes its best guess. So, but the nice thing about this is all these defaults can be updated quite simply using the arguments within the function. So before we go on, I want to talk about how to actually make those changes in the syntax. gtsummary uses formula syntax quite heavily. So on the left-hand side of the formula, you are going to do something to select variables. And on the right-hand side, you are going to give instructions. So for this very top label argument, we are on the left picking a single column called age, and we are saying display that as patient age instead of the default age, which would be the variable name, or the label capital H. You can see below that, for the type, we're saying age and marker are continuous variables. So you can use the C to select more than one variable at a time. You can also use all of the tidy select functions available from dplyr and the tidy select package. So that starts with, ends with, last call, contains, matches, anything that you can use within those functions also works here. So this starts with age. There's only one column that starts with age, and it's the column age. We're saying we want everything rounded to 0 decimal places. And then there are some selectors that are built into gtsummary. So all continuous, all categorical, all dichotomous are the most common examples of that you'll see. We'll review one other one when we get a little bit further along as well. So here, instead of using the default statistic of median and interquartile range, I'm saying I want all of my continuous variables to be the mean and the standard deviation. And so when gtsummary looks at that script, it's looking at it like a glue string using glue syntax. So glue is another package from the tidyverse that uh, inserts objects wherever you see the curly brackets. So here, gtsummary sees mean in curly brackets, and it's going to use the function mean to calculate that summary statistic and then plop it right in there. And the same thing for SD, there's an SD function. So you can actually use any function within base R, any function that you create, any function from another package, as long as it's loaded, of course, to summarize these data. And when you have two or more sets of instructions to pass, then you just put those formulas into a list. So like in this example, if we wanted to change age and marker, then we just say age tilde patient age, comma, marker tilde marker level. Just as a note, you can also use named lists, but you can't combine named lists with the tidy select selectors like starts with, or the gtsummary selectors like all continuous. So we created a very base TBL summary object, and we can actually add a lot more information onto that, and we can modify it quite easily too. So there's a family of functions that all start with add underscore, and you can use them to add, comparative p-values. You can put in q-values. You can, if a table's split by treatment, you can add a column for overall. You can add treatment differences, the number of observations, and there's a few other options as well. The modify family of functions all begin with modify underscore, and they modify attributes of the table, like table headers, footnotes, spanning headers, and actually a lot more. But those are the most common ones to know about. And there are other functions like bold and italicize, which will help you bold labels or significant p-values, what have you. So let's look at a couple examples there. So here, looking at our code on the left, we see that we're using the small trial data set, and we are going to do TBL summary, and we're going to have the statistics split by the treatments the patient received. Add P is going to add a p-value comparing the two groups, the two treatment groups. And then here we're also adding a correction for multiple comparisons using Bonferroni's method. So the add Q function can add a correction to any p-value column, and it's actually running p.adjust in the background, the base R function, and you can use any of the methods within there, like false discovery rate and quite a few others actually. And if you were using this interactively and you were using add Q, for example, it will print into the console exactly the code that's running in the background so that there's no ambiguity about what's actually happening, because that's something I find scary when using a new package. When if I'm calculating like a marginal or conditional mean, I want to know exactly what they're doing in the background, because sometimes I feel depending on different fields, they have different definitions of things. This is another example of an add function. This is add difference. This is one of my favorite functions because I do personally do a lot of studies where we're comparing two treatments or a randomized trial, for example, where we are just looking at how things change between, how things are different between two groups. So in this example, let's say that these patients, we want drug A, drug B, that's what they received, and we want to know how their tumors responded and what their post-treatment marker levels were. And it's very, very simple to do that by just piping in an add difference function, and it will look at this marker and say like, oh, that's a continuous variable. I'm going to put in a mean difference there. That's the default. There are all types of differences you can add. It's going to put in our confidence interval for the mean difference and the p-value. And you can see here that it's very clear that it's using the calculations from a t-test. So that's quite useful to also know exactly what's happening in the background. It looks here at tumor response, and it sees that it's a dichotomous variable, and so it's going to give us a rate difference. And then also here at the end, 2 sample tests for equality of proportion. So that's exactly what's happening in the background. Okay. And one more table with add examples. Here we have again our base summary table from TBL summary. We're adding, that's split by treatment. We're adding a column overall for all patients using the add overall function. We're adding in a column with the n, with add n, And then we are also adding this stat label. So this isn't adding another column per se, but what it's doing is it's removing the footnote that told you what the statistics being presented were and added that statistic label to the label row. So you can see here the label for age is no longer just age, it's age, comma, median IQR, so that we can easily see that age is reporting the median, the IQR. There are 189 non-missing observations. Overall, the median is 47. And when you split it by treatment, the medians are 46 and 48. Oh, I said that was the last example, but there's one more for the add family. There's a very general function called add stat. This will help you add any kind of column to a TBL summary table. It lets you define exactly what's going to happen. So in this example, there's a function that instead of just returning a p-value for a t-test, for example, it's returning the t-statistic and the p-value. Like, I don't ever need this table, but it's just here to illustrate that you can add anything you want in a new column using add stat. The new column that you add, it can go on the label row for age, for example, but if you had a categorical variable, for example, grade, which was 1, 2, 3 were the levels, you can add statistics onto each one of those levels. You can add a single column at a time. You can add 2, 3, 4 or more columns if that's what you're looking for. So it's quite generalizable. And honestly, it's actually a function that's used heavily internally to produce a bunch of the tables when we're starting to add information to them. So here we are with a couple of styling functions. We're going to go over bold labels and italicized levels and bold P. So I think those are all pretty self-explanatory. Bold labels is bolding the label rows. So age, grade, tumor responses are now bold, and italicized levels, we are italicizing the levels grades 1, 2, and 3, also the unknown row when it's there. And bold P is bolding significant p-values. By default, the threshold is 0.05, but to get actually things to bold in this table, we had to increase the threshold to 0.8. So that's what that is doing there. And now we want to talk about these modify functions. Oh, before I move on, I want to mention that bold and italicized functions, they work not with just TBL summary tables, they work with every single GT summary table, just FYI. These modify functions are similar. These are general functions that work for every single GT summary function. So we're starting off again with our basic table. We have a TBL summary, split our summary statistics by treatment. We don't want a row for missing. So I put missing equals no. And we want to change the default header from drug A and drug B that included the sample sizes, and I just want it to be A and B. So I'm using modify header to modify the header rows for stat 1 and stat 2. So A and B, that's stat 1, stat 2. And there's a function in the background to be able to make all of these names visible. That's show header names. So if you just pipe your TBL summary object into the function show header names, it will show you the current labels and it will show you what their true underlying column names are so that you can very easily make these kinds of updates. This modify spanning header, that's going to add a spanning header. This this function all stat calls is a GT summary select helper. And what that does is it selects all of the statistics columns like stat 1, stat 2. If it's a TBL summary object that's not split by a treatment, for example, then the column is called stat 0. It picks all of those columns by just saying all stat calls. And instead of having no spanning header, I now have a header drug. And I wanted to modify the footnote and to put more details. Instead of just putting median IQR and n%, I wanted to say median and IQR for continuous variables and n% for categorical. So that's just a quick example of how to make some simple changes to your table. There are other functions to make even more modifications, and you can check them out on the reference sheet on the website of the package. All right, if there are no questions, I will continue. There's another function called TBL cross, which gives you cross tabulations. This is actually a pretty straightforward wrapper for a TBL summary, but it's really great because it can make these crosstabs for you very simply. And you can also pipe a TBL cross object into add P, and it will give you the appropriate P value here. And I'm using this source node option to tell the p-value function to please place the p-value as a source node rather than a new column like it would for TBL summary, for example. I just want to show you that these things exist. You can have percents in here be the row percents, the column percents, the cell percents, no percents. You can show row margins, column margins, no margins. It's very simple to make these customizations. Just briefly want to say that there's another function called TBL SVY summary. So what this says is essentially it's a copy of TBL summary, but for survey data. So if you work with survey data, this can be quite helpful as well. And we're not going to spend much time with it today, but there's also a function called TBL surfeit, which tables surfeit objects. So here we are just building a very simple surfeit Kaplan-Meier estimator, and we just plop it into this TBL surfeit function, tell it the times that we want to report, and then to make it a little bit cuter, I updated the default headers to say 12 month and 24 months instead of 12 time or time 12, or I've forgotten what it actually is. And oops. And you can see here that add P also works here. All right, I just want to take a quick break, make sure that people are still there. Are we still good?
Yep.
Okay, good. All right, let's move on to summarizing regression models. So you've all seen the traditional summary of a regression model in R. It is messy. It's not easy for others to understand oftentimes. It's not easy to digest. So thank goodness we have this function now for us where you can very easily, before I go on, by the way, this is a logistic regression model using age and stage to predict tumor response in our data set. Okay. So you can see here by just dropping that model object, that GLM model object, M1, into the TBL regression function, you get a nice summary of the regression model here. So you can see that it identifies our model as a logistic regression model. And so instead of just having a beta in the header, it's saying, okay, this is the log odds ratio. It's giving us the 95% confidence interval and the p-value. So that's what it displays by default. You can update it if you want more information. But some of the things I love most about it are what I already mentioned, being able to automatically identify the type of regression model you've got and make appropriate headers. The other one is to automatically find the reference rows for you. This is, I find, one of the most tedious things that I end up doing when I'm copying and pasting results from a console into a manuscript, for example. But I no longer have to deal with that tedious task, which is fantastic. So let's customize this table just a bit. I think what you would probably want to do first is exponentiate those slope coefficients to get odds ratios. So use exponentiate equals true. There is a function called add global p, which rather than reporting p-values for each of the stages here, it is reporting a single p-value for the variable stage, which is a common task for us statisticians and biostatisticians. And then there's actually this new function that I was just showing off here called add glance table. So if you're familiar with the Broom package, it's what's powering a lot of these tables initially. And there within the Broom package, there's a function called glance, which returns a bunch of statistics about a model. So the number of observations, the log likelihood, the AIC, BIC, and a lot more actually. So you can add all of those types of statistics to the bottom of the table. I don't see this as common in our type of research, but it does appear a lot in psychiatry and economics and these various fields. There are lots and lots of models supported, which is fantastic. So this is a partial list of things that we've confirmed that indeed actually work, but I do know that there are other model types that people are using that is not in this list. And I also want to point out that even if the model is not in this list and not supported by default, you can write a custom tidier. So what's happening in the background is when I pass a GLM object to TBL summary, one of the first steps is that we pass that model object to the broom tidy function. If there is no broom tidy method for your model type, then you can write your own very easily oftentimes and just pass that function to the tidy fun argument in TBL regression. So even if you're working with some pretty strange model types, you can still use the gtsummary package. One that comes to mind immediately are cure models. Cure models aren't proper modeling objects in the R sense, and so it doesn't always work out when you want to summarize them. So in addition to multivariable regression models, there's a function for creating a series of univariable regression models called TBL UV regression. So in this function, what you do is you pass it a data frame, you tell it what your outcome is, you tell it the regression method that you're going to be using, you pass any arguments that you may need to go to that regression modeling function. And then essentially the arguments are the same as TBL regression, like exponentiate. So in this example, we're passing the small trial data set. We are going to be using GLM function, so method equals GLM. Our outcome is response, once more, so y equals response. And method.arg is a list of arguments that will be passed to GLM. And what it's going to do is it's going to use every other data column in the data set as a covariate, and it's going to build a series of univariable regression models. So you can see here that and then at the end it stacks them all together. So you can see there's a column n, and the n is different for the various models because there are different rates of missing this in the data for each of the columns. Otherwise, it looks quite similar to your typical regression output. And now I mentioned this earlier, this is the inline text. So like I said, creating tables that are really reproducible, and beautiful is quite important, but reporting those results in the text of a report is also incredibly important. So every GT summary table, the results can be printed in inline text, but these examples are going to pertain to regression tables. In the inline text function for regression models, there's a pattern argument. And what that does is it's going to be the default, how it's going to extract the information from the table and display it. So in this case, if you don't specify it yourself, it's going to give you the estimate, the odds ratio that is, in our case, the 95% confidence interval, the lower and the upper bound, and then the p-value. So let's show an example. Here's our univariate regression table that we just made. And you can see here age has an odds ratio of 1.02, odds confidence interval 1 to 1.04, and the p-value is 0.10. So in your code, you would be writing your R Markdown report, and you would say the odds ratio for age is, and then you would invoke that inline text function, drop in the TBL regression or UV regression object that you already created, tell the function that you were looking for the age variable, and then it will give you the following line in your report, that the odds ratio for age is 1.02 and the 95% confidence interval is 1 to 1.04, p-value 0.10. And you, of course, using the pattern argument, can change that to whatever you'd like it to be. All right, so we've covered a bunch of different types of tables, but one of the most important things that we need to be able to do is we need to construct kind of complex tables oftentimes. And what that means is the previous tables we reviewed are kind of like the building blocks of more complex tables. Those parts are usually everything that we need, but just not all together. So there are these functions, TBL merge and TBL stack, that are fantastic for constructing more complex tables. So we're going to go over a pretty somewhat straightforward example where on the left here we have a univariable table of regression models. So you can see here that we're using the trial data set once again. We are selecting age and grade and this outcome, death and time to death, because it's a time to event outcome. So because it's time to event, we are using Cox-PH, the Cox proportional hazards regression model. Our Y, our outcome, is serve time to death on the status of death, and exponentiate equals true to get our hazard ratio instead of a log hazard ratio. And we're going to once more use add global P. And then we're kind of have the similar model on the other side, but instead of it being a series of univariable regressions, it's a multivariable regression. We wanted to show those regression models side by side. So here's each one of them individually. They look very similar. The numbers are a little bit different because one's multivariable and one's not. So you can just drop the list of any number of gtsummary tables that you would like to merge as the first argument, and then optionally you can give a title for each one of the objects, each one of the summary objects, and you'll add that as a spanning header. So you can see here in the resulting table, we now have a single table with univariable regression results on the right and multivariable regression results on the left. Oh, swap that, excuse me. And you can also merge in summary statistics from a TBL summary, any other gtsummary table, you can merge that stuff in. So while merge merges things from left to right, you can stack things vertically. So let's take another similar example where we have a regression model, T3, that we're making, and it is a univariable regression, unadjusted. So we're looking at the unadjusted difference between the treatment groups here. And we are piping that into a TBL regression object. And while treatment is usually displayed as multiple rows as treatment A and treatment B, using the show single row argument, you can take something that's dichotomous, that's shown on multiple rows by default, and show it on a single row. And we're updating the label, and we're going to exponentiate. Taking very much the same approach on the adjusted model, we are looking again at primarily what we're interested in is the treatment difference, TRT, but we're adjusting for stage, grade, and marker. And when we pipe that into TBL regression, we use this include argument to say, okay, while my model includes 4 covariates, I only want to include one of those in the output. And let's see what we get. So we get 2 very similar looking tables, slightly different hazard ratios. Fantastic. Not unexpected, I don't think. And you can use TBL stack to stack them. So you can now have an adjusted and an unadjusted estimate in the same table. There is another function called TBL strata. It creates stratified tables. So any gtsummary function that takes a data frame or a survey object as its first argument can be used with TBL strata. In this case, what we want to do is we want to make TBL summary tables stratified by grade. So within each of the tumor grades, we want to go in and create this TBL summary defined by this. So this syntax is very similar to what you'd see in the per map family. You put a tilde front, and the .x represents the stratified table, data frame, I should say. And then you construct it that way, and you tell TBL strata that you want to stratify everything by grade. And then it will, by default, create each one of these TBL summaries within each grade and then merge them. You can also stack them in the end if you'd like, FYI. Now, these are a lot of tools for creating a lot of different types of tables, but I also just wanted to point out that these can be combined in very unexpected ways. There was a group of epidemiologists who reached out on Twitter or maybe on GitHub and said, oh, can you add a table like this to gtsummary? We really like the package. It would be really helpful for us. And I didn't think that this specific table was a good fit for gtsummary because it's quite specific. But I said, well, what we can do is we can use the tools of gtsummary to make a new function for you called TBL CMH for the Cochrane-Mantel-Hansel test, and you can put that in your own department's package. And so that's what's being done here. So I just wanted to review exactly how this was done. So you can see in the orange, that's the most basic table that we're working with in this table. So that's just a TBL cross where the total line, the margin line for total has been renamed to crude. And so what we did is we did a TBL cross for controls. We did another TBL cross for cases. Then we merged them together. Then we use add stat to add on the odds ratios and the Cochran-Mantel-Hansel odds ratio. And then at the end, we stacked them all together with TBL stack. So it's actually pretty simple to construct this table. Um, and now they have their own table, and it is a GT summary table, so they can still use things like inline text and all the modify family of functions and the bolding and the italicizing. All of those things work with all GT summary objects. So because they used the tools within GT summary to create this table, it has a lot of other benefits as well.
Hey, Dan.
Yes.
We actually have one question so far. Amazing presentation. But Audrey asked if a footnote can be added with the variables that are not presented, like the adjustment variables for your previous slide.
Oh, for this one? No, this one?
I think so.
Yes, yes. So you can use modify footnote to add any footnote you'd like, and you can place it anywhere in the table. You can put it in the header, you can put it in the body, anywhere you want to put it. You can make a custom one.
Okay. And I actually also had a question for if you have certain arguments in your um, method of regression that you're using, like you showed Cox PH, and I know there's an argument in Cox PH like robust standard errors equals true.
Yeah.
Is there a way to sort of pass that in to the method? Sorry if you already.
So for the unadjusted, for the univariate table or for the multivariable table?
I guess for either. Yeah. Probably
So
for.
if you wanted to do it for the multivariable table, you would just add that
Oh,
robust option here
okay.
when you're creating the model object. And
Mhm.
if you wanted to do it for the univariable tables, because here we're just specifying method Cox PH, right?
Mhm.
But you need to specify an additional argument. I think there's an example of this a little bit back.
Okay.
Yes, right here. So here we're doing a GLM and we have to
Gotcha.
pass family equals binomial to say it's a logistic regression. So in this method.args um, argument, you pass a list of additional arguments that will be applied to GLM.
Okay. Awesome.
So yeah, there is that functionality there
Cool.
to customize. All right. So themes are one of my favorite things that I don't think anyone uses. So maybe you could use it and let me know what you think or how they could be made better. But it's a way to, in a single line, set a bunch of different defaults. So the defaults in the GT summary package, they pretty much follow the published reporting guidelines from the 4 top journals in urology. Now, I'm an author on those guidelines, so which is why I think everything should look like that. But I understand that there are other journals that want things to look differently. You may have seen that the large p-values were rounded to a single decimal place, where many other journals want those rounded to 2 decimal places. There are some journals who don't want a p-value at all. And what we want to do with themes is to easily, very, very simply say, oh, I'm going to be publishing to this journal, for example. Therefore, can you make all of my default output look like their published tables? Or not even for a journal, you could say, these are all of my preferences. Here's my own theme. And so make all the defaults across all of the functions look exactly how I would like, for example. So, like p-values get reported in essentially every table. And if you want all your p-values reported to 5 decimal places, which I don't agree with, but if you wanted to, you could use a theme to say all p-values everywhere in the entire package, 5 decimal places, please. So let's just look at a couple different themes that are available within the package now. So this is what your default TBL regression table looks like with it adds a reference row, adds the labels, the odds ratios, what have you. This is what we're looking at. If you're going to be publishing in JAMA, you may just want to put this at the top of your script, theme GT summary journal, and you say, I'm going to JAMA. So while the TBL regression call is exactly the same, TBL regression M1 model object, exponentiate please, yes, you can see here that the p-values are rounded differently. They're rounded to 2, the large p-values are rounded to 2 decimal places. You can see that the confidence interval and the odds ratio have been merged into a single column. And you can also see that instead of a comma between the lower and upper bounds of the confidence interval, it says 1, 2, 1.04 or lower bound to upper bound. So that's how they publish their tables. So there you go. There are some other changes that are made within TBL summary too for the JAMA theme, for example. Like they don't report a percent sign next to their percentages. They just put the percent in parentheses. So it's like n percent parentheses, no percent symbol. So that is something that's also there. So you can change a lot of things with themes. There are language themes. I think there are 14 different languages that it will GTSummary can translate the statistics into a bunch of these languages. So you can see here that the word characteristic has now been translated. For this translation specifically, the person who helped us out said OR is probably best to stay as OR instead of something else. So they just kept OR, and you can see here that the abbreviation in the table has been updated, the translation. One of my favorite themes is called compact. So you just set this at this theme gtsummary compact at the top of your script, and all of the tables that are produced will be with a smaller font and with reduced padding. In the GT package, the default padding is quite large, which I think looks nice until you put it into a report and every table is taking up more than one page. So this is one of the ones I use all the time. Here's a small example of my very own theme. So this is using this theme element. They're kind of funny names, but it is what it is. These are not things you probably want to memorize. I haven't memorized them. So this p-value fun is saying, I want to use this function to round and style all of my p-values instead of the default. And so that's what will happen. So you can see digits 2 means, oh, everything will be rounded to 2 decimal places at least. You can use these GT customizations to reduce your font size, to add a default title and subtitle to every table. We're also adding a source note that says the date that the table was created. And this this adds row striping to the table, and then this last one removes all of the lines from the table. So let's just take a look what that looks like. So you can see here we've got some striping, we've got no lines, we have that this table was created on the 24th of April, default title, and again, the TBL regression call is exactly the same. So what I would love is for everyone on this call who publishes in various journals is to submit journal themes for the journals that they publish in, so that we have a large suite of themes for journals that we can very, very easily create. So please, please, pull requests to the GitHub page. Welcome. If you don't speak Git in GitHub, we can still do it. We'll just have to work together, which will be fun. So we're getting close to the end of the time. So I want to talk about print engines. So every table you've seen here has been printed with the GT package. The GT package is really beautiful and really easy to use. It's from RStudio, and I think it's really going to be just, they say, like, the ggplot of tables, which is quite, it will be everywhere essentially. The HTML output for GT looks fantastic, but PDF, RTF, they're currently under construction. The tables look really good, actually, but if you start doing a lot of customizing and trying to make them look a little bit more complex, you will get some weird formatting things, and that is because they are under construction and not fully released. So, of course, as researchers, we oftentimes need RTF to share our documents with collaborators in Word. So maybe GT isn't going to be the best option for you. You can use cable. The tables are not as cute. There's no indenting, there's no footnotes, no spanning headers, but that's possible. My backup option is always to go with Flex Table when I'm doing Word output, because Flex Table has really beautiful output, really flexible formatting as well. And if you are creating an R Markdown document into Word, if you have Flex Table installed, gtsummary will automatically just print your tables with Flex Table, which is great. And there are other options: Cable Extra, Hux Table, Hux table is great if you need the LaTeX code, the raw LaTeX code for your tables. I will often use this as Hux table function to convert my GT summary table into a Hux table, and then use the Hux table function as LaTeX or to LaTeX, just to save the raw LaTeX code for a table. And then later I will insert it into my LaTeX document, and I never, ever, ever have to create tables in LaTeX, which is, if you've ever done it, the worst thing ever. Um, I also wanted to show you how you can use these functions from these print engines as GT, as Hux table, as Flex table to make your own customizations to the table. So here we're using the trial data set. We are doing a very quick summary for variables age and grade using TBL summary. Very, very basic, no arguments at all. But we do is we take this GT summary object and we convert it to GT with the as GT function. So that's, once you have a GT object, then you can use every single function within the GT package to customize. So there's a calls width function that you can specify the precise width of every column. So here, all I've done is make the first column, the label column, much larger than the default. And I've taken the statistic column and I've made it left justified. So this, of course, would work with flex table tables, Hux table tables, everything that works with this. Whatever engine you're the most comfortable with is the one I would recommend you use. All right, so we're getting close to the end. Um, if you have questions, the first place you should go is to the website. We've put a lot of time into the documentation. If you check out the articles, there are long form vignettes for TBL summary, TBL regression, inline text, and others. There's an entire table gallery with many, many unique tables that you may need or similar to what you may need. So it includes the output table and the code to create it. So that's can be quite a valuable resource. When you want to install the package, you can just install straight from CRAN with install packages GT summary, or you can install the development version from GitHub. Very soon we're going to get our first 100,000 installations, which is wild. And even today we're getting about 11,000 a month, which is just so much more than I think than we ever anticipated getting. So thank you for sitting through this long presentation. If you have questions about how to use Stack Overflow, visit the documentation. If you have further questions, if you have questions, visit the website. If you have further questions, please use Stack Overflow. If you post a question there and use the GT summary tag, me and some other authors of the package will be notified, and we typically respond within a few hours or a day or 2 days, right? So that's everything. Any questions?
While people are thinking of their questions or formulating them, I just wanted to say thank you so much, Dan. That was incredible. I've been using GT Summary for a year and a couple months now, and I, didn't know about add difference. I don't know how.
Oh, that's a useful
And
one. It's kind of
it's
new.
amazing, yeah. And the themes I'm excited to use. There's so many like really quirky journal themes, like Lancet wants the little midway dot, and like things like that.
Yes. Oh yeah,
That
there's
would
a
be amazing
Lancet theme and it
to collaborate with.
replaces all of the
Okay,
periods with the midway dot. So,
perfect. Yeah, really great.
and with
Okay, I
the add
see some.
difference function as well, you can do adjusted differences. So for example, if you have a randomized trial that was stratified randomization and you need to add those into your models, it can be adjusted that way. If you have, just an observational study, you can adjust those differences there as well.
Yeah, yeah, I'm really excited to look into that more. You have a few questions in the chat. It's a great talk and great work comment, but what have you learned since putting GT Summary on CRAN? Asked Michael.
Oh, that maintaining packages on CRAN is a lot more work than I thought it would be. If you go look at the change log, so the release before this current release, the entire change log is no changes, but I was required to submit because of CRAN. Like, I just had to, one of like the dependencies of a dependency was taken off of CRAN for like less than 12 hours for some silly thing. And it was immediately put back up, but because that dependency of a dependency was removed for a few hours, every single downward dependency had to like submit a new version to CRAN, even though as soon as it went back up, all of the CRAN checks were passing again. So it was, I mean, just little things. There's a million little things about working with CRAN that are quirky.
And then Audrey asked if we can combine the compact theme with others like JAMA or one of our own.
Yes, exactly. So all of the themes are stackable. So you just call them in the order that you like. And the one that's called last will take precedent if there are overlap in the things that they're controlling. And if you ever call themes and you need to undo them, there's a function to reset the themes as well, which happens to me often when I'm trying to write a new theme.
Cool. All right, awesome. Does anyone else have any last minute questions? I think, yeah, I think this was great to have so many people on and so many different groups coming together. We will be in touch soon about future computing clubs and what ours will be for WCM. I think for our WCM people, our next one will probably be Nick at the end of May 25th, I believe, at 1:00 on Julia. So stay tuned for that, more information, and whether we sort of want to open it up again to all these organizations. GT, do you
Thank
have
you
any?
so much, Dan. It was an awesome presentation. I'm definitely using that from now on. Sorry, I haven't been using that, but I will definitely use it. That
Apology
explains a lot.
accepted.
That explains a lot how beautiful my students' tables have been. This recorded lecture will be posted on our website. I am putting that on the chat board so that everybody would have an access to it. You could go and check on our previous presentations there, and we will notify there on the website as well about the future sessions as well. Thank you so much, everybody, for joining. We would make sure to keep in touch and inform you of any future events coming from WCM. Thank you so much, Dan.
Thank you.
Thanks,
Bye
Dan.
bye.